Hi friends, welcome to all. In this video we are going to see the lab activity configuring IPv4 static and default routes. Here we can see our topology diagram and addressing table. We will go through the objectives of this lab activity. In part 1, set up the topology and initialize devices. In part 2, configure basic device settings and verify connectivity. In part 3, configure static routes. In that, configure a recursive static route, configure a directly connected static route, and configure and remove static routes. And in part 4, configure and verify a default route. Now we will go to the required resources for this lab activity. We require 2 routers, 2 switches, 2 PCs, console cables, and Ethernet and serial cables. So we are going to do this lab activity in the packet tracer. First of all, we will design this topology. Here we can see set up the topology and initialize devices. So we will do it in our packet tracer. We required 2 routers, 1941 router, then 2 switches, 2960, then we require 2 PC, we will do the connectivity now. So here we can see we have to connect the DCE at the router R3. The interface serial 0/0/0/0. We can see this interface is not available in this router, so we are going to add this interface to this router. Now we will add serial interfaces to these routers. Coming to the router, we will put off the device and we will take serial connection, high speed 1 interface. We are going to add to this free slot. So when the power is on, we cannot add the module, so we have to switch off, then we have to add it, then we have to switch it on. And coming to this router, we have to switch off the device, then after that, after adding this module, we have to switch it on. Now we will connect the devices from R3 serial 0/0/0 to this R1 serial 0/0/1. Now we are going to use a copper straight through cable from a gigabit Ethernet 0/1 to fast Ethernet 0/5 and gigabit Ethernet 0/1 to this switch fast Ethernet 0/5. Again from my S1 to this PC fast Ethernet 0/6 to this PC. Here fast Ethernet 0/18 to this PC. In the topology, here we can see on the device R3 we have a 2 loopback interface. So we are going to draw that, and later we will configure that. So here we are going to draw it. Now we will rename and label all the devices. This is R1, this is R3, here we have S1, here we have S3, this is PCA, PC-A, and this is PC-C. Now we will place the nodes for the interface names. Before that we will check the clock side, that means the DCE side. So we'll cross check that. Oh, here we can see we connected wrongly. Means actually according to the topology we have to connect the DCE on the device R3, but we connected at the R1. So we will change this connection so that the DC will come to this router R3. We will take this connectivity and we will start from R3 so that we will get the DC connection this side on the router R3. Serial 0/0/0 to this router serial 0/0/1. Now we will check the yes, now here we can see this side is a DCE, so we will mark that here, DCE, right. Now we will mark other interface details. This is a serial 0/0/1, and here we have serial 0/0/0. This is loopback 0. This is loopback 1. This is gigabit Ethernet 0/1. Also on R3 gigabit Ethernet 0/1. This interface is fast Ethernet 0/5. Other side on S3. Oops, this is not a gigabit Ethernet 0/. It's fast Ethernet 0/5. Oh, here we made mistake, right? No problem. We'll delete that. So here is the interface. Now we will mark this interface fast Ethernet 0/6. And here we have fast Ethernet 0/18. Well, now we completed the part 1. Now we will come to part 2, configure basic device settings and verify connectivity. So we are going to configure the devices according to our addressing table. Here they given the instruction to configure IP settings on the routers. For the interface serial 0/0/0, given the IP address, and we must set the clock right and no shutdown command. Now we will come to the router R3. CLI no, enable configure terminal. Here we are going to the interface serial 0/0/0, and we are going to set the IP address 10.1.1.2 and the subnet mask 255.255.255.252, and we have to set the clock rate 128000. No shut. Now we will set up the loopback interface. So we have to go to the interface loopback 0, and we have to set the IP address 209.165.200.225 and the subnet mask 255.255.255.224 and no shut command. Now we will go to the next loopback interface loopback 1, and here we can see changed state to up, protocol changed state to up. Well, now we will give the IP address 198.133.219.1 and the subnet mask 255.255.255.0. Now we will configure the gigabit Ethernet interface. So coming to the interface, gigabit Ethernet 0/1, and we are going to set the IP address as specified in the addressing table and the subnet mask 255.255.255.0, and we will give an offset command. Now we will configure the device R1. Enter the initial configuration dialog. No. Enable configure terminal. We will go to the interface serial 0/0/1 and we will set the IP address for this interface and the subnet mask 255.255.255.252. Now we will give an offset command. Now we will configure the interface gigabit Ethernet 0/1. We will set the IP address as specified in the addressing table and the subnet mask 255.255.255.0 and offset command. Now we will configure the PCs. Coming to PCA, desktop IP configuration, IP address 0.10 and the subnet mask coming to the default gateway 0.1. Coming to PCC, desktop IP configuration, subnet mask, then default gateway, it's 1.1. Also here we can see we must configure the basic settings on the routers. We have to configure the device names as shown in the topology and addressing table, then disable DNS lookup, then assign class as the enable password and assign Cisco as the console and VTY password. Save the running configuration to the startup configuration file. Right, we will do this also. Coming to the router R3, configure terminal. Here we are going to set the host name as R3. Now we will disable the DNS lookup. No IP domain lookup. Also we will set the enable password. We have to give enable a secret as class. Also we have to set the console and the VTY password. So we have to go to line console 0, password as Cisco, login. Now we will set the password for line VTY 0 to 15, password as Cisco, login. Right, now we will save the configuration. Now we will configure the basic settings on the router R1. Enable configure terminal. We will set the host name as R1 and we will disable the DNS lookup. No IP domain lookup. Now we will set the line passwords. Coming to line console 0, password as Cisco, login. Also we have to set the line VTY 0 to 15, password as Cisco. Also we have to enable secret as class. Now we are going to save from running config to startup config. Now we will come to step 4, verify connectivity of the LANs. Test connectivity by pinging from each PC to the default gateway that has been configured for the host. From PCA, is it possible to ping the default gateway? From PCC, is it possible to ping the default gateway? So we will verify this connectivity. Coming to PCA, command prompt. First of all, we will check the default gateway. Here we can see that. So we are going to ping to 192.168.0.1. Yes, we are getting the replay. Now we will try from PCC. Command prompt. Here we are going to give ipconfig, and here we can see the default gateway 192.168.1.1. ping 192.168.1.1. Yes, we are getting the replay. Yes, here we are able to ping the default gateway. Here also we are able to ping. Coming to B, test connectivity by pinging between the directly connected routers. From R1, is it possible to ping the serial 0/0/0 interface of R3? We will check that. Coming to the router R3, password is class. Oops. Yes, Cisco. Now we will go to enable password is class here. Right. Now we will check the IP address of serial 0/0/0. Show IP interface brief, and here we can see the IP address. It's 10.1.1.2. We'll copy this address and we will ping. Ping to this address. Here we can see success rate is 100%. So we able to ping. Here we can see, we will mark that we able to ping. Yes. Now we will come to C, test connectivity between devices that are not directly connected. So we are going to ping from PCA to PCC, from PCA to loopback 0 and loopback 1. Right, so we will try this. First of all, we will try from PCA to PCC. Ping to PCC. Here we can see destination host unreachable. Now we will try to loopback 0. Here we can see the address. Coming to PCA, ping to loopback 0. Here we can see destination host unreachable. Destination host unreachable. Right. Now we will try to loopback 1. Ping to loopback 1. Destination host unreachable. So here the result is no. Here also no. Here also no. Were these pings successful? Why or why not? So here we have seen these pings were unsuccessful. Here itself they mentioned not directly connected. That means these networks are remote networks, so it is not going to communicate. It's possible only after configuring static routing or dynamic routing. Coming to step 5, gather information. Check the status of the interfaces on R1 with the show IP interface brief command. How many interfaces are activated on R1? Right, we will check that. Coming to R1, CLI, password is Cisco, enable, password is class. Here we are going to give the command to show IP interface brief, and here we can see the interfaces. Two interfaces are up, that is gigabit Ethernet 0/1 and serial 0/0/1. So here we can give that. How many interfaces are activated on R1? It's 2. Coming to B, check the status of the interfaces on R3. How many interfaces are activated on R3? Right, we will check that. Coming to R3, password is Cisco, enable, password is class. Here we are going to give the show command, show IP interface brief, and here we can see interface details. Here we can see gigabit Ethernet 0/1, serial 0/0/0. Also we can see two loopback address, two loopback interface, loopback 0 and loopback 1. So total we have 4 interfaces activated. Four interfaces activated on R3. Coming to C, view the routing table information for R1 using the show IP route command. What networks are present in the addressing table of this lab but not in the routing table for R1? Coming to the router R1, here we are going to give the command show IP route, and here we can see the networks, connected networks. Right, coming to the topology. So in the routing table we can see only the networks which is connected to this router R1. So according to the addressing table, other addresses, that means the network of this PCs, this network won't be there in the routing table. Not only that, in this loopback interfaces, that is loopback 0 and loopback 1 address also not present in this routing table. So these all remote networks which will be present in the routing table of R1 after configuring either static routing or dynamic routing protocol. Coming to D, view the routing table information for R3. What networks are present in the addressing table in this lab but not in the routing table for R3? And why are all the networks not in the routing tables for each of the routers? Yes, that already I explained. Coming to R3, we will check the routing table of this device. Show IP route, and here we can see that total 4 networks are connected to this router R3. The topology itself, we can see that here we can see one network, here is another network, and we have 2 loopback interface also. Also we cannot see the address of this network, I mean including PCA and the interface gigabit Ethernet 0/1 on the router R1 in the routing table of R3 because it's a remote network. Coming to part 3, configure static routes. In part 3, you will employ multiple ways to implement static and default routes. You will confirm that the routes have been added to the routing tables of R1 and R3, and you will verify connectivity based on the introduced routes. So this lab provides minimal assistance with the actual commands necessary to configure static routing. However, the required commands are provided in Appendix A. Test your knowledge by trying to configure the device without referring to the appendix well. Coming to step 1, configure a recursive static route. With a recursive static route, the next hop IP address is specified. Because only the next hop IP is specified, the router must perform multiple lookups in the routing table before forwarding packets. To configure recursive static routes, use the following syntax: IP route, network address, subnet mask, then IP address. Coming to A, on the R1 router, configure a static route to the 192.168.1.0 network using the IP address of the serial 0/0/0 interface of R3 as the next hop address. Write the command you used in the space provided. Now we are going to configure a recursive static route. Here we are going to consider this network, that is 192.168.1.0 networks. Here we are going to give the next hop address, that is the IP address of this interface serial 0/0/0 on R3. So we will do that on R1. Password is Cisco, enable password is class, configure terminal. Here we are going to give IP route 192.168.1.0. Now we have to give the subnet mask, prefix mask 255.255.255.0. Now we have to give the next hop address. So here we can see that forwarding router's address, so that we are going to give your 10.1.1.2. So we are going to copy this line and we are going to paste it here. Coming to B, view the routing table to verify the new static route entry. How is this new route listed in the routing table? Right, so we will check that using the command show IP route, and here we can see that static route. Obviously it looks like this. Next is from host PCA. Is it possible to ping the host to PCC? We will verify that this ping should fail. So if the recursive static route is correctly configured, the ping arrives at PCC, so it goes to PCC, but PCC sends a ping reply back to PCA. However, the ping reply is discarded at R3 because R3 does not have a return route to the 192.168.0.0 network in the routing table. Exactly. So anyway, we'll try this ping from PCA to PCC. Coming to PCA, command prompt. Here we are going to ping to PCC. And we are waiting for the reply. Request timed out. No, we are not getting the reply. Now we will see that with the help of simulation mode. So we will select add simple PDU from PCA to PCC, and we are going to click capture or forward. It goes to S1, then it goes to R1. Now this R1 in its routing table, it has this networks, so it will go to this PCC. We are going to give capture or forward again. It goes to R3, S3, and to PCC. Then we can see it goes back to S3, and it will go to R3, and this will be discarded. Here we can see that the message is discarded. So here the answer is no. Right. Coming to step 2, configure a directly connected static route. With a directly connected static route, the exit interface parameter is specified, which allows the router to resolve a forwarding decision in one lookup. A directly connected static route is typically used with a point-to-point serial interface. To configure a directly connected static routes with an exit interface specified, use the following syntax: IP route, network address, then subnet mask, and then exit interface. Coming to A, on the R3 router, configure a static route to the 192.168.0.0 network using serial 0/0/0 as the exit interface. Write the command you used in the space provided. Right, we will do that. Coming to the topology, here we can see the network 192.168.0.0, and this static root we are going to configure in the device R3 with exit interface. Here we can see that serial 0/0/0. Coming to the configuration on R3 router, password is Cisco, enable password is class. Configure terminal, here we are going to configure a directly connected static root, IP root. Then here we can see destination prefix 192.168.0.0, then prefix mask 255.255.255.0. then we can give the exit interface. You can use the serial, so serial, here the exit interface is serial 0/0/0. We are going to copy this line, right, write the command you used in the space provided right here, or the space we will paste it here. Now we will come to B, view the routing table to verify the new static route entry. How is this new route listed in the routing table? Right, we will see that. Coming to the router R3, we are going to give the show command, show IP route, and here we can see that static route. We are going to copy that, and we will paste it here. Yes. Coming to C, from host to PCA, is it possible to ping the host to PCC? We have to try that. The ping should be successful. It may be necessary to disable the PC firewall to ping between PCs. Right, that is in the real systems we must disable the firewall. Anyway, we will ping from PCA to PCC. Coming to PCA, command prompt. Here we are going to ping to PCC. Yes, here it is. We are waiting for the reply. Yes, we are getting the reply now. So here our answer is yes. Now we will come to step 3, configure a static route. On the R1 router, configure a static route to the 198.133.219.0 network using one of the static route configuration options from the previous steps. Write the command you used in the space provided. Right, so first we will implement the configuration on the router R1. Coming to the topology, here this network 198.133.219.0 network is of this loopback interface, loopback 1 interface. We are going to teach this remote network in this router R1 with the exit interface serial 0/0/1. Coming to the router R1, password is Cisco, enable class, configure terminal. Here we are going to give IP route, then the destination prefix, so here is that, then the prefix mask, it's 255.255.255.0. now we are going to give the exit interface, that is serial 0/0/1. we are going to copy this code and we will paste it here. Coming to B, on the R1 router, configure a static route to the 209.165.200.224 network on R3 using the other static route configuration option from the previous steps. Write the command you used in the space provided. Right, so this here we can see this network is of a loopback 0 interface. We are going to configure in this router R1 with the next hop address, the IP address of this interface serial 0/0/0 on this router R3. Coming to the router R1, here we are going to give IP route Then the destination prefix here is that. Then the prefix mask, it's 255.255.255.224. Then here we are going to give the forwarding router's address, that is 10.1.1.2. We are going to copy these commands and we will paste it here. Right. Coming to C, view the routing table to verify the new static route entry. How is this new route listed in the routing table? Alright, we will cross check that. Coming to R1. So here we are going to give the command show IP route, and here we can see that. Yes, here is it. We'll copy these 3 lines and we will paste it here. It's look like this. Yes, here we can see that. Coming to D, from host PCA, is it possible to ping the R1 address 198.133.219.1? Yes, obviously, because we configured a static route to this network. We will check that. Coming to PCA, command prompt. Here we are going to give ping command to this address. It's 198. Give 198. Right. Yes, we are getting the replay. So here the answer is yes. Now coming to step 4, remove static routes for loopback addresses. On R1, use the no command to remove the static routes for the 2 loopback addresses from the routing table. Write the commands you used in the space provided. So here itself we already copied the static route configuration for the both loopback, that is loopback 0 and loopback 1. So with the help of this code itself we can remove very easily. I'm going to copy this code. Then coming to R1, we have to go to configure terminal and we are going to give no and then this commands. Also we will copy the second commands. And we are going to remove that using no and then the commands. Right. Now we will copy these commands and will paste it here on the second one. And here we can see that commands. Next is view the routing table to verify the routes have been removed. How many network routes are listed in the routing table on R1? Is the gateway of last resort set? So both we will cross check it now. Coming to R1, we are going to give the command show IP route. And here we can see that loopback routes have been removed. And now we can see only 3 routes including connected in this router. Here we can see one, here we can see the second one, and here is the third one. And here we can see gateway of last resort is not set. Yes, in the routing table on R1 we have 3 routes. Also, is the gateway of last resort set? No, it's not set. Coming to part 4, configure and verify a default route. In part 4, you will implement a default route, confirm that the route has been added to the routing table, and verify connectivity based on the introduced route. A default route identifies the gateway to which the router sends all IP packets for which it does not have a learned or static route. Well, a default static route is a static route with 0.0.0.0 as a destination IP address and subnet mask. This is commonly referred to as a quad 0 route. In a default route, either the next hop IP address or exit interface can be specified. To configure a default static route, use the following syntax. Here we can see that IP route, then 0.0.0.0, then subnet to mask also as 0.0.0.0, then the IP address, or we can specify the exit interface. Configure the R1 router with a default route using the exit interface of serial 0/0/1. Write the command used in the space provided. Coming to the configuration, configure terminal. Here we will give IP route 0.0.0.0 space 0.0.0.0, then the exit interface, that is serial 0/0/1. Now we will copy this command. We'll paste it here. Coming to B, view the routing table to verify the new static route entry. How is this new route listed in the routing table? Well, we will see that. Show IP route. Yes, here we can see yes star. So we will copy this line. And we will paste it here. It looks like that. Next is, what is the gateway of last resort? Right here itself we can see gateway of last resort is 0.0.0.0 to network 0.0.0.0. So this is nothing but the default route, and here they mention very clearly a default route identifies the gateway to which the router sends all IP packets for which it does not have a learned or static routes. So here is the answer for that. And coming to C, from host to PCA, is it possible to ping 209.165.200.225? And from host to PCA, is it possible to ping the 198.133.219.1? These pings should be successful. Alright, we will verify that. Coming to PCA, command prompt. Here we are going to try this. Right, yes, we are getting the replay. And the next one, yes, here is that. Yes, we are getting the replay. Yes, here we able to ping to these addresses, that is loopback interfaces. So here the answer is yes and yes. Here we have some reflections. A new network 192.168.3.0/24 is connected to interface gigabit Ethernet 0/0 on R1. What commands could be used to configure a static route to that network from R3? So here we can use either of these codes, IP route 192.168.3.0, then the subnet to mask 255.255.255.0. Then we can give exit interface serial 0/0/0, or we can use the next hop address, that is 10.1.1.1. Next is there a benefit to configuring a directly connected static route instead of a recursive static route? Yes, obviously. Here we can see that with a recursive static route, perform multiple lookups in the routing table before forwarding packets, but in the case of directly connected static route, the exit interface parameter is specified, which allows the router to resolve a forwarding decision in one lookup. Here is the last question. Why is it important to configure a default route on a router? A default gateway tells the device to contact the next hop of the default router if they don't have a more specific route. Without a default route, a router will drop a request for a network that is not in its routing table and send ICMP destination unreachable to the source of the traffic. Well, that's all in this lab activity, configuring IPv4 static and default routes. Friends, if you have any doubt regarding this lab activity, please comment below. Also, if you like my video, give a thumb and don't forget to subscribe the channel so that you will get latest uploading video info into your mail. Thank you.